1. In your textbook, this is pages 260 through 263, and for practice, you'll complete all of Exploration 5.1. In Chapter 5, we will discuss comparing two groups, where the response variable is categorical. When we have two categorical variables, we need to identify which is the response and which is the explanatory. The response variable will dictate what a success and what a failure is, while the explanatory variable will tell us what two groups we want to compare. The summary measure in this scenario will be the difference in proportion of successes between the two groups. We could also look at what's called relative risk, which I will discuss later in this PowerPoint. The parameter for the difference in proportions will be pi1 minus pi2, or the difference in true proportion of success between groups 1 and 2. The subscripts 1 and 2 define our groups, which mean they come from the explanatory variable. Our statistic would be p hat 1 minus p hat 2, or the difference in sample proportion of successes between groups 1 and group 2. It is extremely important to define your subscripts. In other words, tell me what 1 represents and what does 2 represent. Or you could use words or letters in the subscript to make them informative. As far as plotting two categorical variables, we can use a two-way table to display the counts, similar to the two-way tables you saw in the probability examples, or a segmented bar graph to help visualize our raw data. Let's look at an example. A survey asks people how often they exceed the speed limit. The data are then categorized into the following two-way table of counts, showing the relationship between age group and response. What would one observational unit be? One person surveyed. How about the explanatory variable? And what is the response? It would make sense that the age group would be explaining how often someone exceeds the speed limit, so age group is the explanatory and exceed limit the response. Notice in a two-way table, we will typically put the explanatory variable as our column headers and the response variable as our rows. Do you think this is an experiment or an observational study? This is an observational study, since we did not assign the age group or the explanatory variable. This two-way table pictured consolidates our raw data so you can see the number of successes, always, and failures, not always, for each group, under 30 and over 30. Pictured is the output from the two proportions applet. I typed in the observed number of successes in group 1, 90, and failures, 100, as well as the observed number of successes, 40, and failures, 170, in group B. Remember, a success meant they always exceed the speed limit. Failures was not always. Group A was under 30, and group B was over 30. Then I clicked Use Table. The segmented bar chart and the difference in proportions was then produced. The segmented bar chart stacks the proportion of failures on top of the proportion of successes for each group. In other words, the applet found the conditional proportion of successes in group 1, 90 over 190, and plotted that, and then found the conditional proportion of failures, 100 over 190, and plotted that on top of my proportion of successes. Notice that these must add to 100, because I'm looking at the proportion of successes and proportion of failures within group 1. It did that same process for group B as well, or the over 30 age group. We could also represent the conditional proportion of successes in a sample as p hat and use subscripts to denote groups. So, p hat 1 would be 90 over 190 or 0.4737. P hat 2 would be 40 over 210 or 0.1905. Again, defining my subscripts, 1 represents those under 30 and 2 would represent those over 30. These conditional proportions help us to see the difference between the two groups. If the difference in conditional proportions is large, that gives us a hint that the variables may be associated, though we need a p-value to determine that for sure. We can also see this in the segmented bar chart if the bars do not look alike. Here, it appears the young age group is more likely to always speed than the older age group. The observed difference in proportions is 0.283, or p hat 1 minus p hat 2 is 0.283. This would be interpreted as the proportion of people over 30 who always speed is 0.283 higher than the proportion of people under 30 who always speed. This value would be our observed statistic, or the observed difference in proportions is the observed statistic for two categorical variables. As stated before, there is another option besides the difference in proportions for a statistic for two categorical variables, and that is what's called relative risk, or the ratio or fraction of the two proportions. In this scenario, our relative risk would be calculated to be 2.296. You must be able to interpret this value. One possible interpretation would be to say those over age 30 are 2.296 times as likely to always speed as those under 30. Notice there is no word more in here. We would say it's 2.295 times as likely, not 2.295 times more likely. If you want to talk about how much more likely or less likely something is to happen, you need to subtract 1 from your relative risk. In other words, you could say, those over age 30 are 1.296 times more likely to always speed than those under 30. We could also change relative risk to a percent increase or percent decrease. In doing that, we take the relative risk minus 1 and just multiply by 100. If that number is positive, we should talk about the percent increase. If it's negative, we would talk about the percent decrease. For this scenario, we would say those over 30 are 129.6% more likely to always speed than those under 30. In a table, what would no association between our variables look like? In order to show no association, the conditional proportion should be the same in each group. That does not mean both groups need to have 0.5 as the conditional proportion. In this example, it would simply mean that the proportion who always speed is the same in the over 30 and the under 30 group. Given a table, how could you create a no association? We could use the overall proportion of successes to help us. The overall proportion of people who always sped was 130 over 400, or 32.5%. So we should see that 32.5% conditional proportion in both the under 30 and the over 30 group, or 32.5% of the 190 under 30 people should always speed, and 32.5% of the 210 over 30 people should always speed. In other words, we would get the following table, which requires the same margins as before, but would show no association between our variables.